Now, when we are talking of missing data, we have to understand the concept of not available in details. We have to understand that in RStudio, N stands for not available. We have to understand that every value which is missing or which is not available is very crucial. We cannot just ignore that place. We have to think about it, that if a value is missing, what should we put over there? Can we reject it? Can we ignore it? Or can we replace it with some approximate value? So that is why dealing with NA or not available values is very crucial when we are preparing the data for analysis. We have seen is.na function for finding missing values. We have seen in our previous lectures also that is.na function is a function which returns a logical vector. It returns a logical vector that indicates all the NA values present. So, if it returns a Boolean value, then if NA is present in a vector, it returns true. And if not available is not present in the value, then it will return false. In this example also, you can see x is a variable where we have created a vector of the values where you can see there are 4 NAs. So, is.na function is passing the vector x and returning the logical vector which is in the form of output. You can see a list of true, false, false, true, true, true. So, that is how we are able to understand. First of all, we are able to understand that whether there are not available values present in the vector or not. So, if the values are present in that case, first of all, we have to understand, shall we go about that data? Which function is basically for non-missing data. Which function in our programming language is used to return the position of the specified value in a logical vector. So, if we have a logical vector, very easily we can find out the position of a particular value. Let's have a look of the syntax, which is a function name. Within brackets, we pass x, comma, arr.ind, comma, usenames. So, let's understand all the 3 parameters one by one. So, the parameters this function accepts, some parameters which are illustrated below, can be understood very well with the help of an example further. So, you can see over here, x, this is the specified input logical vector. This is our input logical vector. arr.ind, this parameter returns the array indices if x is an array. So, if your x is an array, arr.ind will return the array indices. Usenames. This parameter says the dimension names of an array. So, basically here it will give you the dimension name of the array. Now, return value. Every function returns a value and the question mark is that what this function will return. This function returns the position of the specified value in the logical vector. In this example, which function returns the alphabetical position of the specified letter? For example, A is the first letter in the alphabet sequence and that is why 1 is returned and Z is the last letter in the sequence, so 26 is returned. Let's have a look how we apply which function. Now we are calling the which function to return alphabetical position of the given alphabet. Here we have used the which function. Within brackets we are writing letters is equal to A, letters is equal to D, letters is equal to Z, letters is equal to G. So you can see over here that we have given the variable letter which is equated to A, D, Z, P and G. And you can see the output that we are getting the position of the letters as an output. So for A we get 1, for D we get 4, for Z we get 26, for P we get 16 and for G we get the position 7. So basically the which function over here is returning the alphabetical position of the specified letter. And then you can see that we have applied a condition over here and with the help of that condition we are returning the position. So in the below example, the position of some elements of the specified vector is being returned with the help of which function. First, we are creating a vector of some elements, vector C, where 3, 5, 1, 6, 12 and 4 is the vector. Getting the position of the element 12, how we get it? So, we write which vector equal to 12, and then we are getting the position of element 1. We write vector equal to 1. Likewise, we are also doing for 6. So then we get the position of the element 6. So when we are looking for the position of the element 6, we get the output 4. And that is how we are trying to find out the positions. And you can see the output on the right hand side and you can relate with the code. Let's have a look of another very interesting function which is called as the sample function. So suppose I want to create a sample data. So consider the vector data which is equal to 23, 45, 21, 34, 5, 6, 7, 8, 86, 45 and 3. So this is my data. Get 4 random elements. Now suppose I want 4 random elements out of this vector. What will I do? Very simple. I'll write print, and within print I'll call the sample function, and within the sample function I'm passing the data as my variable, comma, number of random elements I want. So I pass data comma 4. So basically now this function will generate a sample of 4 numbers out of this data set. So you can see the output. The output is 45, 7, 5 and 34. Likewise, I pass get one random number. So print sample data comma 1, I get one random number 3. Get 6 random numbers, again sample data comma 6 and I get 6 random numbers which you can see in the output. So basically sample function is used to generate samples of data of a particular data, removing records with missing data. How can we go about it? So to understand, let's consider this particular code snippet. Here in this example, x1 is a variable which is creating a sample of data from NA 1, 2, 3, 4 and 20. So 20 means what? I'm generating 20 numbers and replace equals to true. So replace is a property which is equal to true. Likewise, x2 is a sample of 20 numbers from a data set NA 5 and 10. x3 is another data frame, x4, x5, x6. So I have 6 variables and all the 6 samples are there in the data frame passed as x1, x2, x3, x4, x5 and x6. So you can see over here that in the data frame there are 6 columns ranging from x1 to x6 and all the 6 columns are random numbers. So my data frame is of size 6 columns and 20 rows and the name of the data frame is df. You can see the output in the right hand side where you can see the data frame. In the data frame, if you observe the data, there is lot of NA which is not available. So you can see that I have created a sample data where not available is also present. Now, my query is that if I have to remove certain records where a particular value is not available, in that case, what will I do? That is my question mark. Now, let's understand what is happening over here. You can see I have called the data frame df and within square brackets, I'm applying a filter condition. Now, the filter condition is like is not applicable df $x1, which means is not applicable is selecting the first column, which is the x1 column from data frame. And I'm saying is NA exclamation, which means I'm reversing the value of is NA. I'm reversing the value of is NA, and in that case, what is happening? That wherever there is not is NA, which means wherever there is data is there, in that case, select all the rows. So you can see the output over here. In this output, you will see that I have all the values. You can see over here, I have all the values, but if we have a closer look, we will come to know that row number 3 is missing, row number 6 is missing, row number 8 is missing, row number, likewise, if we see that row number 19 is also missing. So why those values are missing? If we see why those values are missing, we will come to know that in those particular rows, the value of x1 is NA. The value is NA over there, and that is the reason when we have applied a filter and we are saying is NA, if is NA is true, in that case we were printing. So here we have done for x1 attribute is NA is false. If I am putting exclamation, I'm saying is NA is false. In that case, I'm getting all the rows. So that particular column, I have applied a filter on the basis of NA. And if is NA is not there, the entire row is missing over there. And that is how I'm selecting the rows of x1 that does not contain a missing value. Because the condition is such that I am displaying the data frame on the result. And the data frame is catching the NA, catching hold of the not applicable values or x1. And on that filter, the entire row is omitted from the complete list. Now, let's have a look of one more example and understand better. Here you can see that we have done the same thing, but here we have pulled x2 column and not x1. So you can see over here we are pulling the x2 column, and in the x2 column, if not applicable is present, we are removing that row. So we are removing the rows on the basis of not available values in the x2 column. And then followed by comma, nothing is written, which means all the columns will be displayed. So you can see here in the output once again that x1 is basically having the values where NA is displayed on the screen, but you will see that x2 column is not having any of the NA values. And here you can see that row number 2 is missing. As you can see from the data, row number 2 is missing, and if we see the original data, in the original data, row number 2 and variable number x2 has a NA value. So you can see 2 is missing, after that 7 is missing, after that 10, 11 is missing, and then you can see 16 is missing, and after that 19 and 20 are also missing. Why 19 and 20 are missing? Because in 19 and 20 also, for the column x2, the value must be not available. Resetting the data frame index. Now, why there is a need of resetting the data frame index? First of all, we have to understand that index is something that with the help of index, we can very easily fetch a particular value. Let's take example of this data and understand. In this example, we have created our data frame and we are storing that data frame in the variable data. Our x1 is basically a value from 9 to 5. Our x2 are letters from 5 to 9, and our x3 is a variable, a value which is C. So you can see that we have created a data frame. C is the value constant which is coming repeatedly in the column x3. So this is basically our table. Now I write row names. Within bracket I pass data, and with that I equate that to a vector C, which is 41532. So if I write 41532, it means what? It means that for the data which I have created for the data frame, the row names would be 4. The first row will be having a name 4, or you can say the first serial of the first row will be 4. The second row will be having a serial number 1 and 532. So I'm basically giving row names. Now you must be thinking that why we are giving such illogical row numbers? Why not serially 1, 2, 3, 4, 5? Because sometimes it happens. For example, I have a data and I want to give roll numbers, and the data is jumbled on some other logic. For example, top 10 performers. So there the roll number would be different. So in such cases, I am directly assigning row name to the data. So with the command row name and within brackets data, I've assigned the value 41532 into the table. And you can see when I print data, I type data word and press enter, I get the table on the screen. So you can see over here that the first data set, which is 9EC, is having a row name 4. Likewise, row name 1 is having the data 8FC, row name 5 is having 7GC, and so on. So basically, I have explicitly assigned the row names to the data. Now, the question is that how can I reset this data frame and arrange it from 1 to 5? That is a question mark, that how can I reset it? So for that, we have a very good provision.